everyone, thank you for joining us. Today we have a very interesting session about the new update of Azure Data Explorer, the performance update with Engine v3. Today with us we have Avner, Alexander, Alex and Evgeny, which will share with us all the improvement, all the new capabilities from the backend and from the front end. Enjoy the session. We are here. Please don't hesitate to share your questions in the Q&A area. We are here to answer all the requests and answers. Enjoy the rest of the event, and Avner, the stage is yours.
Hi, thank you, Tzvia. Hi, everyone. My name is Avner Aharoni, and I'm a principal program manager in the Azure Data Explorer Custo team. With me are Alex Sloutsky, who is a partner software manager of the Engine team, and Evgeney Ryzhyk, who is the partner software developer who made Engine v3, and I'm very excited to have them with me. So today we're going to talk about the new engine of Custo, which is now a GA. And we're going to do a deep dive into the details of it and show a small demo and talk about other things that we've done with it. So let's start with what did we try to achieve with the new engine. The first is to delight our customers with performance. Performance has always been Custo most attractive and fun aspect of it. You see that there is a auto progress here, so I'm going to just talk through the slides like this. So performance has always been the main attraction of the Custo service, and with the Engine v3 we are making the performance much better, which we are sure that is going to excite and delight our customers. The second goal is to reduce cost. Obviously, some of the cost of every Custo cluster is the CPU that is used for queries. And when you reduce the CPU, this allows you to reduce the cost by reducing the number of machines. And the third thing is to provide a foundation for future innovations, the ability to implement new features, new functionalities. And there are already a few features that we introduced on top of the new engine, and there are more features that are coming. A few words about the administrative part of rolling out the new engine. So the new engine has been GA'd on March 17th last month. And today it's a default engine when creating new clusters. And we're also doing a manual migration of existing clusters to the new engine. Later, we will do also auto migration of clusters. So for those who still have Engine v2 and are content with it, we will do the migration sometime in the future. The goal that we have, the overall goal, is to move all of the Custo workload to the new engine. There is no difference in the charge. There is no difference. We don't charge more money for it. It's just simply an upgrade to the service. It's a complex upgrade. It requires a lot of things to happen in order to get it right. But we consider that as an upgrade, as an upgrade to the service. During the preview, which we did it for almost 6 months, we did not charge the markup meter for the clusters, and we're going to start charging that back on May 17th, which is 2 months after the GA. This is the practice in Azure, and we are just following that practice. So let's talk a bit about the migration and the adoption process. So like I said, all the new clusters are now Engine v3. We already migrated 35% of our customers are already using Engine v3 in one capacity or another. This amounts to 2,300 clusters that are already running Engine v3, and this adoption is rising, and growing quickly by the day. So from here, I'm going to hand it over to Evgeney, who's going to talk about the technical aspect of the new engine. And over to you, Evgeney.
Hi, nice to meet you all. So yeah, I will talk about a few technical details of the new engine. First of all, where it fits. What does it mean? So V3 is basically a new storage format plus a new low-level query execution engine on top of it, and it lives side by side with the current engine V2 that we have, and also with the raw store. So what we have is basically a federated query across all of the engine, in case you have a mix of data. Obviously, when all of the data transitions to the new engine, the old engine will become inactive and it won't be invoked. Next slide. So what we did with the new engine. First of all, we redesigned the storage format, incorporating all of the let's say new features, all of the innovation that was done in this space during the last 3 or 4 years. We completely redesigned our inverted index. As you probably know, text search, free text search was always a strong feature of Cousteau, and we wanted to make it even better because it's one of our distinguishing features. So we redesigned inverted index. It's now much more granular. It helps a lot during query execution. And thanks to this new index, we were able to improve query performance, sometimes even by order of magnitude. The second thing we did is we introduced advanced encoding schemes and algorithms into our storage format. Like we do special encoding for integers, for dates. We improved, somewhat improved the text compression. We do special encoding now for low cardinality text columns, and so on. So these are the improvements to the storage format. On top of that, we now have a low-level query execution engine tightly coupled to this new storage format. And this query execution engine knows how to take advantage of all of the new features we have in our storage. And this new engine focuses, as I said, on the bottom part of the query plan, the part that runs on top of the shard, on top of the new format, new storage format. In addition, we've also redesigned our cache layer, the SSD cache layer that sits on top of Azure blobs, and with which most of the query logic actually interacts. Because when you query hot data, you query it from the cache. So the new cache has much better consistency. It provides much stronger guarantees on what can be found in cache. Also, it utilizes the local SSD better than the old one. So that was a summary of the new features. So the new engine, it's not only about improving the current performance of the current queries. It's also a step forward in overall Cousteau design, because it provides foundations for a few features that we are already implementing or plan to implement soon. And those features are, first of all, fast native query of Parquet files. and it's the same low-level query engine that handles both custom native shards, new custom native shards, and Parquet files. We've introduced result caching for shard-level subqueries, and this feature allows you, in some cases, to reuse partial results from previous queries without manually specifying caching hits. So if you have a query that, if you have a frequent query that does some kind of sliding window computation, where you look at the last 10 hours, then last 10 hours shifted by 10 minutes, then last 10 hours shifted by 20 minutes, and so on. With this feature, most of the partial results can be reused in many cases. Another feature, so another one is stored query results. This is the ability to execute a query and store the result in a kind of temporary table, and then you could query this temporary table again and again. Another feature which will be in public preview soon is soft delete. This is the ability to perform a soft delete on some specific records within a shard. Previously, if you wanted to delete some records, the only option you had is purge, which is a heavyweight process that actually rebuilds the entire data shard. With soft delete, you could specify a query that selects specific records from the shard, from the table that you want to be deleted, and from this moment on, you won't see those results when you query the data. Another feature that uses the new low-level shard query engine that we are bringing with the performance update is sequence analytics. It's a new operator. Again, it will be in public preview soon, that you can use to create kind of state machines that analyze sequence of events. And using this new operator, you could build a sequence detection, funneling, a session analysis, and so on. And it's also, this new engine is also basis for some longer term investments, which will not be in public preview soon, but we are planning to implement them sometime in the future, like seamless column retyping and much more optimized nested column store for dynamics.
Great, thank you, Evgeny. Thank you, that's great.
Thank you.
And so the next part of it is for us was on the journey of creating the new engine, was to test it and to ensure and to measure the improvement of the performance. And since we didn't find a benchmark that was suitable for that externally, we created a benchmark. We did publish the generator. You can see the link in the bottom in GitHub, which you can use. This generator can generate anything between a gigabyte to a terabyte to 100 terabytes. We use the 100 terabyte data size, which is made out of simulating session logs of a typical cloud service. To measure the performance, we created a table that contains structured, semi-structured, and unstructured data, and we created 19 queries that are representing some of the typical queries that we've seen many of our customers doing. And this allowed us to both measure the performance improvement compared with the prior version, and also measurement of new SKU evaluations and as they come through, and regressions, of course, when we do check-ins and when we release new versions. So the next part is for Alex to show a demo of this benchmark and to show how the new engine is performing compared with engine v2. Go ahead, Alex.
Sure, thanks, Avner. By the way, feel free to use Q&A window to ask questions, and Evgeney Avner will pick it up from any point. So if you have questions that you want to team to answer, please feel free. Okay, so I'm going to share a window application that we call Custo Explorer, and if you're familiar with that, probably won't be surprised. It's one of the applications that can be used to query the data sitting inside Custo. And for the sake of showing this kind of demo, let me present you the two clusters that we have here. First one called logs benchmark perf v2, which refers to the previous version of the engine, and the second cluster calls logs benchmark perf v3. Each one of them has the same hardware installed. It's 9 machines based on LV1 SKU, and each one of them has the same databases. So databases that include the logs table, and the difference between databases is the size of the database. For the sake of the benchmark, we're going to show the largest database of 100 terabyte that, as I said, installed on both of those. So if we want to check just for a second before we started how this table looks like, so each one of those has about 400 billion records, and we can take a look how the data looks like. If I hide this window, we'll have more space. You can see that it has timestamp, some kind of source that represents service logs coming from the source, a machine that is producing the trace log level of warning, which can be probably some low cardinality, warning information errors, a component that is emitting a trace log, and high cardinality column called client request ID, which responds to the transaction happens on the service, and the free text message. It also has a column with properties. So let's find one of those where it's not now, where it's not empty properties. Okay, so let's take a look also on the rows that has some values, and the properties is a column, special column that in Custo we call dynamic, and can include different sizes, different property bag arrays or nested objects. So this is kind of data we have. It represents, as we believe, a majority of the logs of the services, and we will try to present real scenarios, not just benchmark scenarios, as we talk. So the idea of creating benchmark was actually to model the real scenarios that we learn people use for real-time analytics over unstructured, semi-structured, and non-structured data. Okay, so I'm going to close this window, and what we have here, we have actually the same queries numbered from 1 to 19. I'm going to show a few of them, and not to bore you, that will represent, and we're going to run it on cluster v3. This is the left side of the tool, and on cluster v2, which is the right side. So the first query actually is pretty straightforward. We are going to filter on a specific hours, 12 hours, and we are going to filter and look for some specific case, something with very common term, like level warning is probably something is not very rare, and also a message enabled is a very common term. So this represents a query when we look for some common term in the corpus, large corpus of the data. So when I run and I compare between engine v3 and v2, actually in v2, for whatever reason it happens, right now it takes more than expected time, but once it completes, we'll be able to see, and I will just run this query again once it's completed. Yeah, we can see that, by the way we can look on the query, that for this we actually access the call data, which is not very expected. Maybe the cluster was restarted, but I guess if I'm going to run this query for the second time, it will be returning faster. So in this case, yeah, in this case we see the call data access is all the data is cached, and we see the real performance of Engine v2 versus Engine v3. Still, we see that Engine v3 outperforms the Engine v2 by factor, but large factor. It's about 20 times faster. The reason behind it, as Evgeny explained, is the more granular indexes, and we actually need to scan less data, even in the case that the message itself has a very common term. We can see that in case that the term is rare, which is the query number 2, representing like checking a different use case, we are expected to see actually that the query, something happens with Engine v2. Well, great that it's not with Engine v3. Let's run it again. Okay, so in this case, that's the expected results, more or less, that we see that even in the case of rare term, both Engine v2 and Engine v3 might work much faster comparing to the common case. And but we still see that the amount of data that Engine v3 has to scan is less. So it also returns in a shorter time. Now let's take something more interesting and try to combine both aggregations and lookups. So in this case, what we are doing, we are filtering on a specific hour, and we are looking for some component that starts with the cloud. So it's that's a filter on a column that is not has not much data, but the message contains response, which may be response or something else. Is probably is going to be a headed operation, and then we are going to aggregate it by the component doing a count. So it actually combines aggregation, filter on the aggregated column, and a message. Okay, and what we see here that in this case the Engine v3 also becomes faster than Engine v2, and this happens because we're actually able to fuse the query of aggregation and the filtering together and utilize the filtering while we use the aggregations. Now jumping a little bit, like let's skip a few other queries that represent here lookup scenarios or search scenarios, and I'm going to jump into aggregation scenarios. Maybe we'll go to this one, query number 8, and start with something quite simple. So what happens here is that that's an aggregation that aggregates by a column with low cardinality. Okay, as you may remember, the cardinality of level is just few values, information, error, warning, critical. And what you can see here that it's also one of the benefits where the Engine v3 outperforms Engine v2, because we are able to utilize the dictionary encoding of the low cardinality columns and actually scan much less data. You can see here, it's very clear here that, resize it a bit, that the data scanned for Engine v3 is way too low than the data scanned in Engine v2. So that also explains the large time difference between for this specific query. It's about 15 or even about 15 times less time spent, and it also of course reflects in the query time end to end. I didn't tell it, but the total CPU time that we are looking here, the layer line, is this aggregation of all CPU cores that require to run the query. So all these 9 machines that are hosting the data are running the query in parallelly, distributed, and the aggregation is this number. So the lower CPU utilization or the lower CPU numbers, that means that we invest less power in computing the same results. And of course, it also reflects in the query time end to end. So we had only spent only 150 milliseconds versus 1.2 seconds for that query. Okay, so that was single dimension, low cardinality. You may think it may fit in the memory, but let's go for something more interesting even here. So let's go for two different dimensions. Now we're going to aggregate by level and by component. Because this query is going to produce large amount of results, we're going to fetch only top 50 of those, meaning that we're going to fetch only 50 rows that correspond to the largest aggregated count. So what we can see here that also in this case, when there are two dimensions and the second dimension is not low cardinality anymore, engine v2 is about 15 times faster. Sorry, it's about 30 times faster, or 20 to 30 times faster in between them. Again, this is due to the fact that we are able to utilize dictionary encoding when it's possible and fuse this query all together. And actually, all of this is being fused as a single query compiled together and run in a way that we know how to fit the query to the data itself. So all this happens within a few milliseconds, and the end-to-end time is 230 milliseconds. So compilation of this query and ability to run this query distributed is quite awesome and very cool feature of the Engine v3. Let's take a look just for to understand that. Let's take a look on the aggregation that has a distinct count and see how that improves in Engine v3 versus Engine v2. And we can see that this kind of query that calculates distinct count is also improved in Engine v3. That's because we are able, like Evgeny said, it's also a foundation and a platform to implement functionality. And once it's implemented, it plays all well together. So in this case, distinct count behaves implemented natively in Engine v3. And therefore, it's able to utilize all the benefits of the platform itself. Now, let's go to query that we didn't yet implement. Like not all operators yet implement Engine v3. You shouldn't care about it too much because whatever Engine v3 is not capable of doing, it delegates to Engine v2 and that completes the work. And to show you an example of how that looks like, let's go to a query that is doing something crazy. Let's go to query 617, for example. What happens here? Let's take a look on it. We look on large amount of data, about 3 days, looking on specific source. We are going to take a command, like a message starting with the ingestion command, which represents some kind of ingestion operation. We're going to deconstruct this message and split it into additional fields. So we are going to parse this message and make unstructured text structure. So we're going to extract a table name out of it. And then we are going to join it with a different messages coming from the same source, okay? The same source. So we utilize the data. And what we are going to count, we are going to count how many different records. So let's say that every single line here represents a properties row count. If you remember the dynamic field I've showed you, we know that for each comment like this, we'll have the properties row count, and joining these two data sets together, we will be able to count the amount of row count per table. Okay, when the table is actually extracted from free text and the count is extracted from dynamic field. Okay, so I can tell you for that neither parse operator join are not implemented in Engine v3, and let's see how that works together. So that means that some of this work will be done by Engine v2, something by Engine v3. As Evgeny showed, it will be query delegation happens in the runtime. So let's see the competition between two engines and see what happens here. Okay, well, it was a slight win to Engine v3. It's still completed faster than the Engine v2, which is nice. And that happens because we actually, even the basic operators of filtering and ability to scan less data already brings a lot of benefit to the everything that happens right after it. And it will improve even more once we get to the point that we implement parse and then think how to optimize and fuse it all together. So next stage will be, if we implement that, it will also be improved. We'll be able to use it all together. So even the cases that we actually didn't complete the all work and that will be happening down the road, we are expected to get even more benefits from the engine v3, as Evgeney outlined, we see it's not just a step, it's a foundation for delivering even more capabilities, even more performance improvements. And another query, also including join, that happens here, we can see that it's not just something that we selected. Specifically, also in different joins, we can see similar improvement here, even 2 times, but the idea is the same. So Avner, I think it's enough for this kind of demo, and I'm delivering back to you.
Okay, great. Thank you, Alex. This was great. I'm going to share my own screen. Okay, and the next slide is to show the actual summary of the performance runs that Alex just highlighted. You can see that the total here is we measured it for 2 types of concurrencies. One is 1 and the other one is 50. And you can see that the 1 was 3.6 faster, the 50 was 9 times faster. The difference, of course, as you increase the concurrency of the queries and the amount of queries, the performance gets faster, and the improvement is more apparent. So this actually concludes the content that we prepared, and this is actually shorter than the 1 hour that we scheduled it for. The next slide is about the different the links that we have for the product. You're all welcome to click on them, to go to them, and learn more about Azure Data Explorer, about Custode. There is the product page, documentation, our cost estimator that allows you to estimate the cost of a cluster and for the workload. We have online courses for the language and how to start with the service, labs, white papers, trial cluster, and many use cases for different customers that are happy with the service and allowed us to document it. Also, please follow us on the social and community network, and many thanks to Evgeney and Alex and Tzvia, of course, and looking forward to meet with you again in the next webinar.
Avner, there was a question, so maybe we can stay a few minutes more and answer the questions. And also there was a question about Elasticsearch, and do we have a performance comparison with other databases such as Elasticsearch? And I think it's worth mentioning that we have lots of customers that moved from Elasticsearch workload to ADX, to Custode, and got large performance improvements and saved cost. And I wonder if you feel free, if you want to say a few more words, so we can paste here also links to case studies that are published around this.
This is exactly what I'm doing right now.
Yeah.
Excellent. Yes. Okay. So thank you so much. And see you.
Cool. Tzvia, do you want to add something?
Yeah, I just want to add a couple of things while I'm sharing the link for the Elastic one. First of all, regarding those links, I would like to mention that there are free courses for the basic of KQL, how to start with KQL, which include end-to-end scenarios and also the advanced KQL capabilities. There is the webinar. This is a monthly webinar. Every month we share different content. It's very nice if you will follow and join the next one. And please also, this is our log that I'm just sharing right now, that you can follow customer stories, new features, new events, and many very nice stuff.
Thank you, Tzia. Yeah, and I see that you published also the.
No, no, it's not the right one. I just noticed parallelism. It's good for ADX, not necessarily for me. So give it another second. Here, this is the right one. Okay, and also I will share some couple of customer stories from that moved Elastic to ADX and are very happy with the performance and from the cost. That's it from my side. I hope you enjoyed this session. As Avner and everyone mentioned before, we are more than happy to get your questions and available for any assistance, and you can find